All right, welcome in, folks, to another special episode of I've Got a Theory. Got a guest here, Andrew Lerario. Am I saying your last name right? No, I'm not saying it. Lerario.
That's correct.
Okay,
you
right.
nailed it. And
Andrew,
rarely people do, so thank you.
Happy to have you on our show. Our kids are friends. We get to hang out every once in a while, a lot, especially before COVID. And you're also a science teacher at High Tech High.
That's correct, yes.
And one of your claims to fame is that you're building a giant rocket.
I was inspired in a project-based school to just do science and not just learn about science. And in doing that, I started noticing kids were getting engaged. And then I started geeking out by, watching what other scientists are doing and to engage in the fields of practice and the communities of practice. And I started doing space science stuff with kids, and that was really hooking them and engaging a more diverse body of students in the science fields. Eventually, we launched weather balloons. Kids got to see the curvature of the earth, and, that just sparked a whole movement there. And I was thinking, well, I teach chemistry. What can I get into? And so we started building rockets. We started with paper rockets, and now we're planning to build a rocket that can challenge the world record for amateur rocketry. We might not make it, but I think engaging in that is a fun and exciting thing to do with students.
What's the record right now?
Oh man, it was like 144,000 feet, but I think it was just past. Now it's like 250,000 feet, and it's
250. That's like 45 miles up, huh?
Oh yeah. People get up there.
Yeah, that's huge, because space is considered about 60 some miles,
it's
right?
The Kármán line. I think it's 50 miles.
50 miles. Okay, that's considered space. Wow. So if you get one into space, what if you lose it in space?
Well, I don't think that we'll be able to, reach.
You're not going to break the gravity
velocity.
Okay.
If we do, that's cool. If we never get it back, we can say whatever we want. I'm kidding. We can calculate roughly how high it goes, and we'll have a GPS sensor on it, so we'll be able to track it as best as we can.
So if you needed Elon Musk to go rescue it from crashing into the ISS, you'd be able to
we'll have to contract people. Yeah, we made a mistake. I was like, it was in the service of education.
We're gonna need a bond pass through the state of California for about 1.5 billion to retrieve your rocket.
Yeah, I'm surprised by how adept the students can be at this. Like, once they actually apply themselves and get engaged, they'll go home and they'll come back and they'll be like, oh, we can redesign this. And I know a person that works, with metals, and they taught me how to use this lathe, and I can help with this nozzle. And so they just start picking it up, and I find myself just kind of running with them instead of kind of directing as much. So it's very decentralized, and it just kind of goes.
Well, I would say the best kind of homework is when you're like, I want to think about this. I have this issue that I'm dealing with on this project. And then you might think about it, you might sleep on it. I know I do that often at work, where I'm like, I slept on this problem, and the next morning I have a solution.
Mm-hmm.
Yeah.
So it kind of goes. I don't think I've actually officially assigned homework in a couple of years, to be honest. And I know there might be some parents out there like, how can you not assign homework? Because they have an assumption that you have to. But I think once you see a student engage, you can't unsee it, and then whether or not a kid's engaged, and you can have a conversation with them about it and get them to a point where they want to do the work on their own.
Okay, so I've got a theory, and I pitched it to you right before we started recording. And my theory is that black holes pull matter and energy and anything nearby into its accretion disk, which eventually gets pulled into the event horizon, which eventually gets pulled down to what we believe to be a singularity, which is like an infinitesimally small point of all of the matter, which could be billions and trillions and tons of matter and unquantifiable amounts of energy and light or whatever it could be, to a point that's nothing, to a point of nothingness. And I think at some point, those points within a black hole get so super dense, they've reached capacity. And capacity, I believe, is what causes the Big Bang. I think that must explode back out into a spray of energy and matter in its most basic form, which is just the hydrogen that blows up out of a Big Bang. And it creates a new universe from that explosion of the singularity of a black hole. That's my theory.
I think that's definitely a plausible idea, because I think when the words we're using here, the idea of nothing, I think there's no threshold in the universe that's an absolute threshold. There's fluctuations around that threshold. So nothing can be an infinity of possibilities. of quantum fluctuations that can produce any set of outcomes. One could be a new universe, you know, and I read a theory somewhere, and you know, I don't know if I could pinpoint exactly where it was, but our universe itself might be a consequence of one possibility of a quantum arrangement that had created our universe.
Yeah.
So if you have a singularity where everything is coming together and you're reaching a point where everything is becoming nothing, well, there has to be some kind of fluctuation around that nothing where every possibility is being realized and then other universes could pop out of that.
Yeah. I mean, yeah, obviously it's a miracle. Like, you know, I sometimes think about how it lined up where the matter has slowly evolved over time into more complex matter, right? When you're just looking at the elements in the periodic table of elements, to go from hydrogen to helium, to go from helium to carbon, to go from carbon to oxygen, et cetera, et cetera, et cetera. You know, took an incredible set of underlying fundamentals of physics for it to work out so well, right? And I guess, you know, one of the theories would be is that there could be other universes where they have a completely different periodic element of table chart of elements.
Yeah,
with completely
different set of physics. Different set of energies, and yeah, it could be completely turned around. I mean, we can already create particles that typically don't exist in our universe. You know, like antimatter and things like that. There might be a completely, you know, and if there's another way, another like a passageway to another dimension or another universe, like I would not want to go there because the physics might not work with the way that my atoms and everything work here, you know?
Yeah, or on the flip side, it's possible that the arrangement that we have with protons, with neutrons, with electrons, and the individual nuclear forces that they have that create the matter that we understand in this on this universe is the only way that it could be arranged to be able to get to some kind of different types of elements that could eventually evolve into something like us.
Yeah, the inevitability, you know, the inevitable consequence of complex chemistry that forms life. And you know,
maybe no other option is possible, right? What if like an electron was just a tiny bit less powerful to have that, you know, atomic gap between that and a proton? It's like, well, it's like, you know, that could change everything. That could change how individual matter is created, and the physics just beyond that itself is so compelling. Or the fact that, you know, gravity has a certain function that's consistent based on mass. If that was off by just a teeny bit, how much would that affect how things float around in space?
Yeah, and I think during the Big Bang, I think there was, you know, antimatter and matter. I think there was, I forget the actual calculation on it, but it was some very, very, very tiny fraction of matter that existed in more of a capacity than in more of an amount than antimatter, and that birthed our universe. So it just happened to be a tiny bit more.
So going back to this theory that it's so we understand that black holes come to some type of singularity. We found out last year, to everyone's excitement, that you can now photograph whatever some kind of blob that looks like a black hole, and they're measuring things, right? I mean, the cool thing is that every year or 10 years or 5 years they put up a better satellite or better telescope of some sort, or some kind of measurement tools that can measure different wavelengths or frequencies or heats or wave, you know, something like that, which gives us a little bit better understanding of these.
It's all the light. I mean, we interpret the universe through the light that we can kind of unpack and see what it means.
Yeah, the light, and you know, the visible and invisible lights that we can interpret. You know, it's incredible when they can look at that and say, oh yeah, this is the kind of wavelength of light that's coming through. That must mean that there's XYZ gas there, and so which is incredible. But yeah, I always think about black holes and think about like it must do something. It just can't be like a one way. It pulls in and nothing ever comes out. Like something must come out at some point. And
they do evaporate. You know, Stephen Hawking theorized the action of virtual particles on the edge of the black hole, where they separate. You know, virtual particles being, again, this threshold where in space you can have a vacuum, but there's vacuum fluctuations where these particles pop into existence, a particle and an antiparticle, and they exist for a short amount of time. And, you know, soon they come together and they annihilate each other. back into nothing. So there's never an absolute nothingness. There's particles popping into existence and, annihilating itself all the time.
Explain that. I have a hard time wrapping my head around matter and antimatter and how something that is there could be evaporated into nothing that's observable.
Well, the idea is that the thresholds in the universe are never actually reached. They exist, but you can never reach absolute zero, or matter would like collapse on itself. There has to be some.
You mean
form of
absolute
energy
zero
there.
in terms of temperature, or
Yes, in terms of molecular motion and energy. I think there was the coldest place in the universe. This guy in I think Cambridge, Massachusetts, made it in his lab, where they took a bunch of lasers and they used the action of lasers on molecules in a V-shaped cone, where they slowed down the movement of helium molecules to a point to get like 1/1,000,000th of a degree Kelvin, which ended up being like the coldest registered place in the universe that we can think of.
wow.
Which I think that's pretty cool that we made
But
that.
it was still moving. They couldn't get it to not move.
I don't think you can
They
get it to
They
not
couldn't
move.
freeze it.
No, maybe like matter collapses on itself if you get it to absolute zero. So you can never really reach the threshold, I believe. And
That's
I
interesting.
think
Yeah, you could get to super density without any kind of motion, huh? Because ideally, it's the physical or the electrical bond that keeps some distance between the particles. Huh? Yeah.
yeah, you
And
have
so
to
without any
maintain
temperature,
some
there's
form
no
of energy.
electricity, huh? Is that what the kind of the theory is?
It has. Yeah, it's all connected. The physics, the physics of the universe have to maintain. So, the idea of virtual particles, and I'm again, I'm not an astrophysicist. I can't go that deep with it, but I know that Stephen Hawking came up with the idea that these virtual particles exist. That there's fluctuations in a vacuum where these particles pop into existence and then they annihilate each other. And in this process, if this happens at the edge of a black hole, and these particles, pop into existence, say one of those particles gets sucked into the black hole. Now it's past the event horizon. That particle is no longer in the timeline of our universe. It is past all events that can occur in our universe, whereas the particle on the outside now exists. And so the particle on the outside, it exists as a photon, shoots off into the universe, it's gone. And the particle that's now inside the black hole takes a toll on the mass and the rotation and the energy of that black hole. And so over time, it causes these black holes to eventually evaporate.
Have we observed that now that we can photograph black holes, does it make sense to kind of look at a couple dozen or a couple million or however many our instruments can do and see what happens over some time, right? Because especially as we look back through space in time, ideally we would see something happening with a black hole, right? Because prior to last year, we just would be like, there's a gap there. We're thinking there's a black hole there, right? It's kind of the idea. But now we're starting to be able to measure and prove with some kind of certainty that there is a black hole, like the one in the middle of our galaxy, the Milky Way galaxy. Now we can look at it, but I'm wondering if we could, one, I guess, is the one thing is, does it seem possible that most galaxies have a black hole, or every galaxy has a black hole, and that's what keeps them together?
I don't know if they attribute the actual act of keeping a galaxy together from the black hole. I don't think there's enough gravitational pull, and that's kind of where like the dark energy and everything comes from.
Yeah.
But I know they actually, again, we're figuring this all out.
Yeah.
It might actually have that action. And going back to what you said earlier, where, well, if these black holes do evaporate, what happens? And eventually, once they lose enough energy, I believe they explode. So there would be evidence of these black holes releasing all their energy back into the universe from black holes that might have existed a long time ago that we might be able to observe. Once we get the James Webb Space Telescope up there and we can look to the beginning of time, we should be able to observe something like that.
We should be able to hopefully find and stare at some black holes long enough and be like, look, something's different happening from this one at a certain point. Instead of just pulling matter in, it just blew up and now we can't observe anything.
Yeah, I believe once it evaporates to a certain point, it loses its ability. I guess the Schwarzschild radius equations break down and everything, and they explode. And I think that's also the theory of the timeline of our universe. Right now, we exist in a point in our universe where our universe is only capable of sustaining life for like a trillionth of a fraction of the actual time that our universe will be here. That most of our universe, after all the stars use up all their fuel, after, every star in the universe turns into a white dwarf, and then they collapse into black holes, and then all the black holes eat each other up. You get into this black hole age where slowly they, eat each other up and evaporate over time, and that's the end of the universe. So,
Or is
you
it the
look at
beginning of a new universe? Do they
well,
all eat each other up?
so what's the evolution of our universe look like? Well, we end up with black holes and they evaporate. Maybe they spark new universes, as you said, and it maintains this cycle.
Yeah. Yeah. Interesting. Wow, shit. And I hate that this is probably one of those mysteries that we might not ever be able to solve unless we come up with, telescopes that are so good that can see this happening in other parts of the universe. We're like, oh, a few light years that way, there's a new universe being formed.
The fact that we've even, been able to come up with this much in the scale of the universe and how small we are, the fact that we can even think of these things and come up with the mathematics to describe it, which is essentially the act of science, I believe, is, figuring out the nature of the universe by removing human bias as much as possible.
Right.
And the fact that we can kind of describe the universe in such great detail and dream about these things that might exist and then go and observe those things and find evidence of the stuff that we've been able to come up with in our heads. I think that's an amazing and beautiful part of being human. And, it really draws these existential questions like, who are we as human beings to observe the universe? And, are we the only beings in the universe that can observe it and assign it meaning? Are we the only place in the universe where meaning exists because we're the only life form that's capable of assigning meaning to the universe?
Well, it's a fundamental part of our evolution that if we weren't curious, we wouldn't have figured things out.
Mm-hmm.
Right? If we weren't like, oh, what happens if I do this? And let's give it a try. Well, if it has a favorable outcome, we're going to do it again. If it has an unfavorable
outcome, it's a visceral
outcome,
kind of like endeavor to pursue curiosities.
Yeah,
and that's the thing that's missing from education. As an educational teacher, they're like, oh, teach them these facts. Everyone has assumptions about what kids need, and it always comes down to teaching them facts, But the act of science and figuring stuff out, to me, is such like it's an intellectual adventure, right? And you're pursuing curiosities. Like questions have answers, and everyone's like, oh, if you're a good science teacher, if you get your kids to ask questions, like because you could just like questions get answered, curiosities get satisfied. There's an intrinsic feeling that you get when you pursue something that you're interested in figuring out,
and then you figure it out. That's huge, right?
And so I think that's what drives us. And there's also I think there's a self-fulfilling prophecy of science too. Like, we project what we want to see in the future in our science fiction, and then we go and pursue it. Like, I can't imagine how many hours and amount of money has been spent on people developing like a lightsaber or something. Like people try to figure out what we dream about. We pursue it. So there's a bit of a bias there, but at the same time, I think that's what makes us human. Like I
would argue that one of the benefits of a good education would be learning how to learn.
Exactly. And I think that's the shift in education right now too. Because kids can go online, information's everywhere. It's ubiquitous. You can go online, you can find not only the information, but the personality that you want to learn it from. So my role as a teacher actually is transforming more into a learning coach. I'm the adult learner in the room, and I can navigate, how to learn by going through these processes and, these skills. But, there's a utility to the way that you can learn, but it's not necessarily learn this, learn that, do this, do that,
Yeah, it's the hey, let me Google this for you because it's there. Now figure it out.
It's there better than I could just riff on it, like it's someone's already.
Yeah, it's not like take notes. It's like, yeah, Google it and we'll figure it out from there. And why don't you do a little project or, come up with the next best thing on it.
Yeah, and that's what I've experienced by pursuing these space science projects with my students as well. So, I mean, going back though, it's we'll eventually look into space and we'll find all, these answers. We'll pursue them. And to me, that's an amazing kind of thing, to think about. I can't wait till the James Webb Space Telescope goes up in 2021.
Yeah, absolutely. I mean, I love hearing all the space telescopes that are coming up, even on the planet that are coming up, the Atacama, large, diameter things and all these kind of things that are popping up. Cause I love reading National Geographic. So I'm always interested, like, what are we going to find out next? The most recent publicized scientific discovery was that they pinpointed the age of the universe to 13.77 billion years.
Yeah.
Give or take 40 million years. Which kind of just gets us towards that, we're drilling down and targeting in on facts, which are observable. And that's the key difference. I remember having this conversation with someone that they claimed they weren't religious, but they were spiritual. And they're like, well, if you believe scientists, then that takes faith too. I'm like, no, it's the opposite, because scientists do things that are verifiable by other people, independent and objectively, right? I mean, the thing is, like, you don't have to believe me. go ahead and prove it yourself. You'll get the same results.
Yeah. Sylvester Gates, I remember he had a talk one time where he was talking about where religion is, it accepts truths, whereas science kind of, we look to figure things out. It's not about, science is about the making and religion's about the maker, I guess, And,
Yeah.
So there's but even in the same respect, we take our liberties in science to just accept things as truths. There's things we call scientific fact. We just accept them as truths, Even words like infinity. Like if we were to sit and think about it, we can't comprehend it. So we just give it a placeholder name and use it in our equations. But we can never wrap our minds around it. The idea of infinity is that anything you can possibly imagine exists. Like that's crazy. Like it's mind-boggling. If we were computer beings, we would just short circuit.
You think it's possible sometime in the future we could limit infinity to a certain thing? Because it's possible that anything that we describe as infinity has a limit or has an end or has a distance.
Yeah, it's impossible for us to discern. Like, I think the universe is so vast that for the most part, just about anything we can imagine within reason, it probably exists. And to me, like, I think that gives a lot of credibility to a lot of these crazy theories that might exist. Not crazy, but just these theories that people might think might be crazy are out there. Like, I believe that there's a high chance that, we're living in a simulation right now.
Yeah.
Because if you look at the things we already do and you would apply infinity to that, or the idea of just like massive scales of time and energy and just evolution to that, like, you got to understand that to the end, you could take anything to the nth degree and it's likely that will exist at some point. So we already run ancestral simulations. We already build, computer systems that can process, artificial intelligence, my kids are building Minecraft cities that are elaborate and everything. Who's to say? And that's how long have computers been around for? Like, you and I grew up in a time where like none of that stuff existed. Like it was.
True. I remember getting our first computer in like 1992.
Yeah. The internet had started. Like you hear these crazy noises and bubbling, and sounded like a coffee machine was going on, and then you get a page that comes up line by line.
Yeah. The best you can do is like chat with people. There's like no real good content.
Yeah. It's a crazy idea to think about now, because now we stare at our phones, and computer screens. But so to imagine that, in the future, with the computing and processing capability to create, a reality that is of high fidelity, that's that you could discern between that and other realities, where you could study, the evolution of human beings, or the evolution of beings like us. I think it's plausible to say that we live in a simulation. Either we do or we don't. I think those are the.
Well, yeah, I think it's possible that the simulation set the physics up for us to evolve and develop how the universe, the galaxy, and the species on our planet and life has evolved here. I think that the physics that were set up could have been predetermined by a simulation.
There's a test for that, actually, that scientists have come up with. And of course there's assumptions in this test, but the test is, according to Einstein's theories, the universe is isotropic, meaning that it's uniform in all directions. Okay. So if you have an expansion, if you have particles that travel in certain directions, they should be able to travel equally in all directions. Okay. With the same magnitude and force and everything else. So the test is, if you are creating a simulated universe, you should be able to study high energy particles like those in, cosmic rays. And if you get down to kind of like the fundamental action of those particles, and you find that they're anisotropic, meaning that they are not expanding in the directions and vectors that you would assume, meaning that, for example, like if you look at a piece of wood, there's grains on it that go one direction. Okay. So you can split a piece of wood easily in one direction, whereas it's much harder across the grain in the other direction. Right. So if that exists for particles on a fundamental level, then the thinking would go that there is a fundamental structure that has been created for this universe that particles can act in, rather than them adhering to Einstein's theory of being isotropic, where they could travel equally in all directions.
Okay, so then what is that? Are we able to prove that test?
Well, you could study it on small scales, I guess, and like particle accelerators and things like that. There's a fear that if you figure it out, it might end the simulation. I think that's part of the cool part of simulation theory is, well, what are the implications of a simulation? Where are we going? And it makes you start thinking about, so, where are we heading? Are we heading towards a collective consciousness? And that could be like, as we, Ray Kurzweil said that as we develop technology and information and we innovate, we don't become divergent from technology, that we become more convergent with it. It becomes more intimately connected to us. Like we're sharing information more quickly. We're connecting thought more quickly. And that, initiates civilization, progress. We're seeing that right now with the internet that came about, relatively recently in terms of, our human civilization.
Yeah, last
It
generation.
started with the printing press. Right after the printing press, people, you had Reformation. The Renaissance started right before. Definitely got like jolt in the arm when that happened. You had the Enlightenment. You had the scientific revolution. All this stuff that happened, and now we have the internet coming. And you're seeing, I think we're in the dawn, witnessing civilization progressing in an exponential rate right now. And
True.
you see people connecting to the experiences of other people all around the world right now and reacting to it, coming to a collective thought around, how we can move forward. So I think eventually we move towards a global society, and then what happens after that, and
Well, then, the goal always should be sustainability for our planet. And then I think afterwards is if we can figure out a way to explore the universe with nominal impact. But I think eventually it's just that robots do the exploring for us. I don't think we humans and organic life can manage space travel as much as just.
Yeah. I mean, like, and we don't necessarily do that,
Right.
like when we go and travel somewhere and explore, we typically bring it back to our cities and build up our cities, knowing what we now know.
Right.
And it's interesting that you say that, because I don't think they're mutually exclusive, exploration and human advancement. Like the further you explore, the more you can look back and see that you're more than what you once were. And it gives you new perspective. Like when we went into space, the Earthrise came over the moon, and that was taken and put on the cover of Time magazine. I think in like 1969. I think that was.
Still an iconic photo. Yeah.
Yeah, and well, that changed everything about how we look at the Earth. Like, oh, the Earth has clouds, and oh wow, it got a thin layer of an atmosphere. And the Environmental Protection Agency came right afterwards, and OSHA came right afterwards. All this stuff came. Earth Day, all this stuff. We started thinking about the Earth just from seeing that one photo. And then, of course, you had the Voyager that went out, and it turned around when it hit Saturn and saw the Earth. And you had Carl Sagan write this pale blue dot speech about the whole thing, where it was a fraction of a pixel in the vast arena of space. And what are the implications of that? So the more we explore, the more we can look inward and look at ourselves. And of all the scientific advancement, the furthest perspective of Earth in this blue dot speech, the conclusion that was drawn of everything that we've been able to figure out was that we have to treat each other better. We have to deal with one another more kindly and cherish and preserve the pale blue dot, the Earth. So take care of one another, take care of the Earth. Yep. And it's cool that of all scientific kind of like discoveries, the implications on human beings and civilization is that we need to take care of each other and take care of the Earth. It just comes back to that.
And that's the most important thing. And people lose sight of it with their own selfish reasons, right? It's like, this is our only spaceship. Let's take care of this thing.
Well, that's our struggle with being human. We are who we are. And I think, all parts of who we are as human beings, we have to confront. And so I believe that, through scientific advancement and exploration, we develop greater capacity to handle, our shortcomings and deal with it in a collective way.
Awesome. Andrew, appreciate having you on the show and talking theories and science and the importance of science, and how important it is to support science, right? I mean, I think that's the key thing, is to support it and trust it. And it's not fake news. This is like science figured out by people that don't have an agenda, but to figure things out.
Well, go experience it. How many kids from inner cities have been out to see a dark night sky? You mentioned the Atacama Desert. Like that should be on everyone's bucket list, to get out there and lay down and stare at the darkest sky and see, and just wonder about the world, the universe.
Yeah, it's incredible when we get out of the city a little bit and you see some stars. You're like, man, it's out there. Because I've been down to Australia and you can see like the Milky Way and stuff, and you're like, holy cow, you can like see the rest of our galaxy
Yeah,
And
let
just
yourself get quiet once in a while. You know,
yeah.
let the world get quiet so your brain can get loud and you can wonder about these crazy things.
Well, we'll have to take a night trip up to Palomar sometime soon.
That sounds great.
That's kind of our closest location. Andrew,
Uh-huh.
thanks for joining me on the show. I've got a theory, Henish Political. We talked about black holes and singularities and a little bit of everything. So thanks for having me on. Hope we get to see you soon.
This was a ton of fun, Henish. Thank you for having me.
Thanks.